Hello and welcome. In this video, we're going to do a program of a task, small task, but it has a lot of new thing to learn for new programmer in Siemens TI portal. A lot of features to cover, and the timer concept is also need to be covered. This TON timer is IEC type timer, standard timer. In new latest Siemens PLC, this is the default uses of this timer. And the first task is where we have a start button. When we press that start button, a flash light will turn on and turn off. It will be flashing for 1 second and flashing that will be off for 2 seconds. But pressing the same start button will change the timing. So in second press, the flashing will be turned on for 2 seconds and off for 1 second. So this is our program. So if we consider and think about these tasks, we'll see one start button is there, and that is a digital input, and flashing of light is normally a digital output. So we need a digital output for this example. In this example, we are also covering how to use FC to solve the problem, because the whole problem is solved within FC function. And then we have used two timer, one timer with single instance, another timer with parameter instance, multiple instance of timers. And then we are stopping the timer in the third press of the start button. So this is we're covering in this example. Now, in previous example we have added a digital input. In this example, I have already inserted digital output. How you can insert? You go to the hardware catalog and select the digital output module you want to add. You can add any of this module, it doesn't matter. We need only one digital output. And for the address changes, you double click on this digital output module, go to IO address and change the address you need. And that's all. And one more thing, you can change the tag name flashlight. I have given the name for this one digital output channel. That is the first channel I have used, is a flashlight. You also can assign the tag name in this PLC tag folder, default tag table, or you can even create a new tag table for this purpose. So this is about the hardware configuration. And second thing we need is the parameter. We are using three parameters for this example. One is the counter, how many times the start button is being pressed. So first time we are starting the flashing with one set of time, and then second time we press, we are running the flashing another set of timing. So we are checking the start button count as well. And then we are using flashing on delay and out delay, two parameters we have used to externally give the value to the timer. And then two things we have created, I will come across again, I will tell it again. One is we have created a data block for timer. Inside this we have used parameter. A variable is declared flashing off timer, which is IC timer data type, and IC timer on DB, which is actually single instance DB for another timer. Now open the example FC. Before opening the example FC, I want to see how you have actually assigned this flash off timer in the FC flashing off timer, which is a multiple parameter instance variable used for one of the timer inside FC1. If you open, this is the example we are starting from the network 5. This DB3 is this one. on the left side. It's a system block because timer is a system block, and we are using single instance. How you can create single instance? Let me show you. You drag and drop this empty box or select the network where you want to insert and click here. This way you can insert an empty box, or I delete again and just drag and drop here. This will also insert empty box. Then you type TON. If you enter TON, a pop-up will appear. This pop-up, it has two options. One is single instance. If you give single instance, it will create a data block with this number. You can manually give a number or automatically. So I have given automatic option and it has created DB3 here. And you can also change the DB name. And then if you want to create parameter instance, then you can change the name and just press OK. The only thing is, for parameter instance, you have to uh, give a parameter when you call this block, just like we have given a parameter from the time of data block. Hope you have understood this one. Now I delete this one because I have done already. So this is DB3 is a single instance because it is taking a whole DB for one system block. But this one, this TON, we have used a parameter instance because in this DB we can use this way. We can use multiple, timer and define, multiple variable for that. Now, coming forward to our solving the problem using ladder logic, we are starting from this point, network 7, the start button. The first time, second time, and third time, these three press, we're keeping a track. When we press the start button, that is 0.2, start flashing, we are taking the positive pulse, increasing a parameter, which is start flash press count, increasing every time we press the start button. Once it reaches 3, that is third time, we are resetting the parameter value to 0. Parameter start flash press count is set to 0, and then reverting back the original time value, on delay and off delay time for the flashing, so that next time after turning off the process, next time when user press the start button again, it starts from the default time value. And also we are turning off the flashing memory bit, which is used to turn on and off the flashing first flash light. So this is our starting point of the ladder logic. Now what about the flashing, actual flashing? Okay, so this is number 5 network and 6. So actual flashing, we are starting from network 6, which is the off delay time timer. And now this count we are taking and comparing with the 0, because when we press the start button, the count is no more 0. It has increased to 1. When we start the first time, it increased to 1, so it is not equal to 0. The result of logic operation of this instruction is 1, true here. And then we're checking this memory bit. We have taken a random memory bit, but we are going to use it for this solving this problem. So when this bit is off, we are running a timer for the off relay. For the first start, it is 2 seconds. So we are running after 2 seconds. This is going to turn on. This Q bit is to be turned on after 2 seconds. So when this is on, we're turning on this bit to block this timer so that it doesn't run. So we'll remain keeping this bit on, and then this bit we are using to turn on the flashlight. So after we start the press the start button, we are starting with the off. Flash remain off for 2 seconds. That means when 2 seconds elapse, we are turning on this bit and turning on the flashlight. Now this is the last instruction we have, last network we have used to assign the digital output, and this is a normal practice that when we assign values to digital output, we do it at the end of the network, end of the program. Now we are going to turn on the on delay timer. The on delay timer will start from this bit. When this bit is on, we are using it here, but we are taking this condition, same condition here, that start button is pressed. It is non-zero and flashlight is on, and then we turning on the timer to keep track of how many millisecond or second the flashlight is on. So in first start it is to 1 second. Sorry, after 1 second our ET will elapsed time is becomes 0. When that becomes 0, the Q bit, the output bit of this timer turn on. So when that happen, we're checking the bit and turning off the flashing on bit M3.2, and that will turn off the flashlight. So this bit is being set in one place and reset in another place. Set and reset is very useful in ladder logic. Set is used when turning on a bit permanently, and it will remain on unless and until you reset it. Just like here, if we don't use the reset instruction, this bit will remain on and forever it will be on, because this memory M3.2 is a retentive memory. In PLC, Siemens PLC, M flags, a range of M flag is retentive by default, and after beyond that range, the M flags are non-retentive. Non-retentive means if you turn off the PLC, the bit status will be erased, so it will be 0 again. Now we are using retentive bits, and that's why when the start button press third time, we are resetting the flashing on bit, just to make sure that the next time when power turn on, in randomly if someone turn off the PLC and it was when the bit is on, so next time when you power on the PLC, because the bit was on, the by default the flashlight will uh, turn on. So we don't want that. We want to start from the beginning. Okay. So where we from network 5. Okay, so when the flashing on bit is off, so we check the last. If it is off, our flashlight will be off as well, because this is just assigning the same status into the output. One thing you can do, you can invert this instruction to NC to switch the timing on time to off time, but we don't want that to be hard coded. We are doing it programmatically using this ladder logic. When the parameter uh, count start flash press count is equal to 2, is supposed to be equal to 2, then we are switching the time period of on time and off time, and that way the on time will be 2 seconds and off time will be 1 second. So this is our whole program. I think we have covered all the network 5, 6, 7, 8 and 9. So let's go to simulation. If we want to simulate, we have to open a what is the worst table. I think we have mentioned it before. Okay, so this is our second press running. We have to start from beginning. Okay, the process is off now. Everything is off now. We are starting. First start, turn on the start button. The count is 1. Off delay, this is on delay is 1 second. Off delay is 2 seconds. That is, the flashlight is on for 1 second and off for 2 seconds. Now if we turn off and turn on second time, it's still 2 second off, 1 second on. If we start it second time, count becomes 2 and our flashlight is now off for 1 second and on for 2 seconds. And the parameter here off timer is 1 second, on timer preset value is 2 seconds. PT is for preset time. And that's all. And if we start third time, it should stop. The whole process should stop. Okay, so count value becomes 0. Everything is stopped. I hope you are not confused with the start flash positive S. This is the positive S memory bit. It is used in detecting the digital input, the start button. This memory that you have seen in this was table is to save the previous status of the input, just to compare the changes of the input to detect the positive value from 0 to 1. I hope you're quite clear the instruction of this example. Start flashing light of 1 second on, 2 second off. Pressing the start button the second time will change the flashing duration, 2 second on, 1 second off. And that was our goal and we have achieved it.